Ladies and gentlemen, today we begin calculus. And the foundational topic of calculus that you need to learn is the topic of limits. Without limits, calculus would not exist. Okay? So by the end of class today, you should understand what a limit is and how to calculate limits given either an equation or a graph. Okay? So by the time you leave class, that's what you should be able to do. That is what is going to be on the quiz on Thursday. All right? So we're going to start out by calling this Intro to Limits. Now, like I said, you can write your notes in pen, pencil, I don't care. Honestly, if you take your notes in different colors, it does help you remember things. So if you're a person who likes color, you have different colored pens, you can do that if you want to. It's up to you. So, the first thing I would like to do is define a limit verbally. We're going to define it mathematically later, but we're going to define it verbally first just because it helps you to understand what exactly it is. A limit is a y value, and that's the one thing you really need to remember, that a function approaches as x approaches a specific value. A limit is a y value that a function approaches as x approaches a specific value. Now, the difference between a limit and just a plain old y value is with a limit, you don't necessarily have to get there. You can get close, but you don't have to get there. Okay? You've been exposed to limits before. They've probably just never called them limits. Okay? When you studied end behavior in pre-cal, that's limits. And we'll talk more about that formally today. Okay? The next thing I want to do is show you how it's written mathematically. This is the notation for limit. Okay? Here's the way a limit is written. These are two things stacked on top of each other. You write the letters LIM, then you do an X with a right arrow, and then after the arrow comes a number, whatever number you're talking about in this case. I'm going to use a 3. And then out to the side you write either f of x or the function's equation, depending on the situation. Now, you need to know how to read that, okay? The way that is read is the limit as x approaches 3 of f of x. The limit as x approaches 3 of f of x. So as I'm teaching, as I say that phrase, you know now what to write down. LIM, x with the arrow, and then the number that I give you. There are two other limit notations you need to be aware of. Here's the first one. I'm going to write it a little bit bigger. LIM, x, arrow, 3, with an exponent, but the exponent is a negative sign. F of x. Okay? The way you read that is the limit as x approaches 3 from the left of f of x. So it's the limit as x approaches 3 from the left. The from the left really goes with the 3. It looks like it goes with the of f of x. But that means I'm getting close to 3, but I'm coming from the left-hand side of 3. How do you think it would be written if I wanted to say coming at 3 from the right? How do you think the notation would look if I wanted to do 3 from the right? With a plus sign, exactly. So you would write LIM with an x and an arrow and a 3 and a plus sign for an exponent. That means from the right. So this is the limit as x approaches 3 from the right of f of x. So the plus sign means from the right, the minus sign means from the left. And probably at this point you still don't know what I'm talking about, and that's okay. We're getting to the meat of it. I've just got to set the stage first before we get going. Okay. Now, one of the things that I try to do in this class, besides teaching calculus, is teach you skills that you're going to need to survive any college math class, because college professors are very different from high school math teachers. And the fact that they write stuff on the board and expect you to totally understand the mathematical shorthand that they use. And they expect that you've been taught that in high school. Well, sometimes you're not taught that in high school. And you're not taught also how to read a mathematical formula or theorem and understand what it means. So we're going to slowly, over time, be reading formulas and theorems in class, and eventually you'll get to the point where you'll look at something and go, oh, I understand what that means. It may take a while. So I'm going to introduce you to your very first one. It's the mathematical definition of a limit. And I'm going to show it to you. Some of you are going to look at it and go, oh, that makes sense. And some of you are going to go, I have no clue what that means. That's okay. I will explain it to you. So here is the mathematical definition of a limit. And it says the following: in order for a limit to exist at x equals a. Why do they use an a? A represents any number you want to choose, comma. In order for the limit to exist, the limit as x approaches a from the left of the function must equal the limit as x approaches a from the right of the function. Okay. Now that I have said that out loud, do any of you understand what that means? I'm just curious. One person does. Okay. If you had just seen that on a piece of paper, do you think you would have understood what it meant? Probably not. Okay. A picture is worth 1,000 words, so I'm going to draw what this is talking about. Now remember that a limit is where you're going, not necessarily where you get to. Okay? So what I want you to do is write the word yes and draw a little graph underneath. Then I want you to write the word no and draw a little graph underneath. All right. We're talking about a limit at x equals a. So a is an x value. So on the x-axis, I'm going to put an a. And I'm going to draw for the yes picture an upside down absolute value that looks kind of like this. It's got a hole, though, at the vertex. So just draw that right there. Okay. How many of you have seen the movie or heard of the movie Honey, I Shrunk the Kids? You seen that one? Very old movie, very good movie, okay? I want you for a minute to consider yourselves shrunk, okay? And you are now a bug, and you are crawling on this graph, okay? The limit means you are a bug crawling. If it says this, that means you're headed towards A from the left side. So that means you're on this side of the graph. Okay, so I'm going to draw a little bug here. Lots of little legs. And he is crawling up the graph that way. Okay. There's a hole in the graph. So that the limit says it's a y value that it's getting close to. There is no y value there. But he's getting close to the hole as he gets close to A, yes? Okay. Now, if you are talking about this situation, that means you're on the right side of the graph. So here's another little bug. Here's your friend, the other little bug, coming to meet you. But he's coming from the right. Are you guys going to meet up at the same place? Yes. That limit exists. So as this bug approaches from the left and this bug approaches from the right, they are approaching the same place, aren't they? Even though it's a hole in the graph. So that is where we have the limit approaching from the left equaling the limit approaching from the right. And so the limit is, it's the y value of the hole. No, because remember A is an x value. They can be the same number sometimes, but it's the y value there that we're looking at. Okay? Can you picture what a no scenario would look like? No, they have to both be approaching the same x value. But how would the graph look? They can't keep going. They have to both be headed to x equals a. So one could be coming up a graph to here, and the other one could be coming up a graph to here. Do you see what I'm talking about? You seeing my hands? So one is coming this way. I'm going to do it under the camera. One is coming up this way, and one is coming this way. They're landing at the same x value, but there's two different y values. Do you follow what I'm saying? That's a no scenario. So let's draw something like that. So the left-hand side is going, say, up to here with a hole. The right-hand side is coming, could be flat, it could be curved, it doesn't matter. It could be a hole or a dot, it doesn't matter. That's a no situation. This little bug crawling from the left is headed to a different y value, or look to be y value, than this little bug crawling from the right. Okay? So, you could be headed to a hole, you could be headed to a dot. It doesn't matter. The point is, where are you going? Not necessarily, did you get there? Have you ever been driving and headed someplace but you run out of gas? Or you have a wreck? I hate to say that people have wrecks. Does it change where you were headed? No. It's just where you were going. Okay? So, this is a yes. In order for the limit to exist, this bug has to be headed to this bug. The left side of the limit has to equal the right side. Question?
This is, I'm just trying to picture, like, it doesn't matter which, like, angle.
The angle does not matter. It matters where you stop. As long as you're headed to the same direction. Exactly. Okay. Any more questions before we move on? Okay. Now, we kind of get an idea a little bit now of what a limit is. Let's talk about how to find it. Okay. So, next page is going to be ways to find a limit. And there are 3 that we're going to discuss today. There's lots, but we're going to start with 3. Okay? So, ways to find a limit. I'm changing pages. Flip. Okay. Is everybody ready for me to move on? Okay, number 1. Given an equation, comma, look at the table. Okay, sometimes you'll be given equations, sometimes you will be given graphs. And sometimes you'll be just given tables. Here's your example. We're going to do the limit as x approaches 4 of the function x squared minus 3x minus 4 over x minus 4. Okay? Now, on these table questions, they will give you a table to start with. So underneath the problem, I want you to draw, we're going to draw a horizontal table just to save paper. It needs to have 2 lines wide, 8 squares in each line. So I'm going to divide this into halves, then quarters, and then each of those in half again. That makes 8 squares. So 16 total squares, actually. And I'm going to put x and f of x right there. Now, when you get the homework, these tables will be pre-built for you. But I'm going to show you where they got the numbers from in this first table. So we're going to actually build it together. In square number 5 on the top, I want you to put the 4, because that's where we're approaching. Okay? Now, this side is looking at, as we approach 4 from the left, this side's going to be looking at 4 from the right. Give me a number just to the left of 4. Closer than that.
3.75.
Let's start with, how about 3.9? That's pretty close. Do you agree? Closer is better, because closer gives us a better look at what's going on. What's even closer than that?
3.99.
Very good. That was nice and stereophonic. What about the next one? 3.99. Now we're really close to 4. Okay? So now let's do the same distances apart on this side. So this one over here would be 4.1 on the far right. Move over 1. What would it be? 0.01. We got to go smaller. Okay, what about the next one? 4.001. Okay. All right. Now we need our calculators. Okay, I'm going to scoot this up a little. Okay, are you seeing what I'm doing?
Yeah, no,
Okay. Go to y equals for me. Everybody take your calculator, go to y equals. It's kind of hard to see right now. I'm going to move it up a little bit more. Okay. We need to put this function into the calculator. Now, real quick, nice little trick that you may not know if you have an 84 with the new operating system. Let's rewind for a second. If you have an 83 or without the old operating system, you need to put the top and the bottom in parentheses when you type it in. Very important. If you have the new operating system, watch this. Push the alpha key. The alpha key accesses all of the new functions the calculator does. Now push y equals. And now push enter. It puts a fraction bar in there for you. So now you can just type the top and the bottom in. You don't need to worry about parentheses. So go ahead and do that. X squared minus 3x minus 4 over x minus 4. Alpha, y equals, and enter if you want to write it down. Alpha, y equals, and enter. Okay? All right. I need to take my calculator away for just a minute because I need to reset my table. Okay. Putting it back. Now, if you go to the table right now, you're going to be given just a straight set of numbers, agreed? But I want these numbers right here. There is a feature the calculator does, whether you have an 83 or an 84, that allows you to build your own table with your own x values. And everybody needs to know what that is. Here's how you access it. Push second and window. Everybody push second window. I'm going to write this down. So we're going to do second and window. And we're going to change the INDPNT. What do you think that abbreviation is for? Independent. We're going to change it to ask. Okay? So basically now, instead of automatically creating a table of x's, it's going to let you ask what x's you want. Now go second and graph to get your table again. Some of you will have a blank table, some of you will not. Does anybody not have a blank table? Okay, if your table is not blank, and you're going to need this later, listen to what I'm saying. Push the delete key right now over and over again. It'll clear out everything that's there. Okay? Are you following me? Is there anybody who's having calculator issues at this point? Okay, what I want you to do is type in those x values straight across the page and then write the y values in that go below it. So 3.9, 3.99, 3.999, 4, 4.001, 4.01, 4.1. Go ahead and copy those into your table. Okay, is anybody having calculator issues at this point? Okay. Anybody else having issues?
Is error 0?
Error is error. There is no y value.
That's the limit, right? Because it can't actually.
Okay, the limit is where you're headed, not necessarily where you get.
Okay.
It gets to error, but it doesn't head to error. Okay? It's like sometimes you're driving and you head to the mall, but you don't necessarily get there because you get a flat tire, or you run out of gas, or you have an accident. Okay. Okay. All right. Has everybody got this copied down? All right. Now, we're going to talk about what this says mathematically. Okay? I want to know the limit as x approaches 4 from the left of this function. Okay? You have to do this every time. You have to do the number from the left, the number from the right, and then just the number. Okay? These are the x values to the left of 4. Remember, the limit is what the y value looks like it's going to be. As I get closer to 4, what does it look like the y value should be? 5. It looks like it should be 5. That's the answer.
Why does it show up error on the calculator?
Because there's a hole in the graph at that point. Okay, let me ask you a question here. If I wanted to know what the y value at 4 was to this right here, what would I do? Plug in 4 for x. Now when you do, somebody quickly plug in 4 to the numerator. What do you get?
16.
16 minus 12 minus 4 is 0. And on the bottom you get 0 also. 0 over 0 is indeterminate. We'll talk more about that at a later point. But it could be anything. It means a hole in the graph. It could be any number. In this case, it's the hole happens to be at 5. Okay? That's because the y values are progressing to 5. We didn't set it. It just happened to be. We'll show you.
The x values.
Yes, because we set the x values that way, yes. Okay, now the limit as x approaches 4 from the right of the function. So here are the y value, the x values to the right. As I go back this way, remember I'm going backwards, what does it look like the y value should be headed backwards? Does it look like it should be 5 also? Yes, the limit is 5. Okay. Therefore, have you all ever seen therefore with 3 dots in a triangle? Yes. Therefore, the limit as x approaches 4 of f of x is what? Well, maybe you don't know. Let's go back. According to the definition, in order for there to be a limit, the left-hand limit, the limit as you approach from the left, has to equal the limit from the right. Do they equal each other?
Yes.
Yes. Therefore, the limit is 5. That's the answer. Okay. Is 5 the y value? No. But 5 looks like it should be the y value. That's what a limit is. It's what the y value looks like it should be. Okay? Questions? All right. Next problem. Number 2. Given an equation, look at the graph. I'm actually going to change this one a little bit. Actually, no, I'm not. I'm going to do the limit as x approaches 0 of the absolute value of x divided by x. Now, we're not going to do a table this time. We're going to actually just look at the picture and do it with a picture. Okay? All right. A couple of things. Some of you may go, I don't remember where absolute value is. The new operating system has it nice and handy. I'll show you both ways. With the new operating system, go back to y equals, clear that out. I'm going to put in the fraction bar. You remember how to do the fraction bar now? Alpha, y equals, and enter. I want an absolute value up there. Here's where that is. Alpha window. Go over to the next one. First choice is absolute value. There, puts the bars on there. X over X. Okay? Now, so it's second. Window is one way to get it. The other way to get it is second 0. Excuse me, I did it wrong again. Alpha window. And second 0 enter is the other way to get it. Alpha window or second 0 enter. Both of them give you absolute value. This on Zoom 4. So as soon as over X, yes sir. As soon as you're done, push Zoom 4. Okay, I'm going to draw a little sketch down here of what I got. I got 2 boring flat lines. Looks like that. Okay. Okay, after you write that down, I want you to write down the following. I want to do the limit as x approaches 0 from the left of the function. I want to do the limit as x approaches 0 from the right of the function, and then the limit approaches 0 of the function. Those three. 0 from the left, 0 from the right, and then just 0.
So now are we going to do the table and just put 0?
We're not going to do the table at all. We're going to do look just at the graph and do it.
Okay.
Avoid the table. Okay?
And what is the zoom for?
What the zoom 4 does, it's going to help us because what it does is when you trace on zoom 4, it always goes by 0.1. And that's what I wanted to do. Okay? Now, I'm going to cover up my picture with the graph itself so you can see it. Okay? When you're going to do it with the graph, listen to me carefully. This says 0 from the left. Give me an integer to the left of 0. What's the integer, number line number to the left of 0?
1.
Negative 1, right? Okay, so I want you to push the trace key, and I want you to type in negative 1. Now, are you sitting, is your little blinky box sitting to the left of 0? Yes. Okay, remember that a limit is a y value. Okay, so what you're going to do is you're going to right arrow and watch your y values until you get to 0. So do that for me. Push the right arrow key and just keep going. Watch your y values until you get to 0. At 0, there's nothing. That's okay. But what does it look like it should be when you get to 0? Not 0. What does the y value look like it should be? Negative 1. That's the limit.
Wait.
Okay, let me do it again. Okay. Let me go back to negative 1. Okay? For a minute, if you're kind of confused, just watch me. Watch the screen. Okay? I am going to push the right arrow. I'm going to move the box towards 0. Okay? I want you to watch the y values. Watch the y values. Because eventually when I hit 0, it's going to go away. What does it should look like it should be right there? It looks like it should be negative 1. Because they're all negative 1s, aren't they? Okay? Now, this one says 0 from the right. What's to the right of 0? 1. So now push 1 and enter. Are you sitting to the right of 0 on the graph? Yes. Now left arrow until you get to 0. Look at the y's. What does it look like the y value should be? 1. Oh, that was fun. My pen cap just flew off. Okay. Yes, sir. Question?
I got it.
Oh, you got it? Okay. Now, therefore, let's put a little therefore there. We don't have to, but I'm going to this time. Therefore, the limit as you approach 0, what? It does not exist. We're going to write DNE. DNE is going to be your friend. This stands for does not exist. Somebody in second period goes, Mean Girls. And I went, oh, yeah. You remember the end of Mean Girls? The limit does not exist. Well, we just did. The limit does not exist. Why? Because the definition said in order for it to exist, the limit from the left has to equal the limit from the right. Because they don't equal, it's a DNE. So anytime they're different, it's DNE. Okay? That's the situation like that. Whoops. All right. Questions? Okay. I need to go on to the last question. I'm not going to have time to do the middle one. I wish I had time for you to practice one of these, but we'll do it later. Number 3. Given a graph, comma, look at the limits from either side. I'm going to make sure I get finished because this is the most important. What I'm about to do right here is what your quiz is going to look like on Thursday. Okay? I want you to draw a rather good sized graph. I need you to mark it off in 5 units on each direction. This needs to be rather accurate. You don't have to number the negative y's because there's not going to be any points down there. turn my paper for a second. Sorry. Please draw that. Right there. I'll give you a second. Okay, is anybody still drawing? Now, I've given you a picture. The equation to this is too complicated because it's a piecewise function, but you need to be able to look at the graph and figure out the limits. Let me show you how. Letter A. The limit as x approaches, let's see, which one do I want to do? I want to do -2 from the left of this function. Okay. So, here's -2. I want you to go to the left of it, not quite all the way to -3. You can go all the way to -3 if you want to, but -2, go up to the graph. So you're the little bug sitting right here on the graph. Can everybody look up here for a second? As you approach -2, what does it look like the y value should be? 1. That's the answer.
Wait, the distance between the two?
No, it has to be, if you're sitting on the graph to the left of -2 and you are crawling towards -2, what does it look like the y value should be? The y value looks like it should be 1. Yeah, downward towards it. Okay? Letter B. The limit as x approaches -2 from the right. Okay, so let's say we start at like -1.5. As you crawl towards the -2x value, what does it look like the y value is going to be? 1 again. You all agree?
So you don't start from -2.
No, you can't. You know, you never start from -2. You're approaching -2, so you're not there yet. Okay. Any more questions? This is how the quiz is going to look. Yes. Okay. Letter C, the limit as x approaches -2 without a plus or minus. If it doesn't have a plus or a minus, you have to look at those two to determine what to write here. What should it be? 1. Who can explain why? Tell me.
Because they're going to meet at the same place.
They're meeting at the same place. The limit from the left and the limit from the right are the same number, aren't they? That's why it's 1. Okay? Letter D. Here's a curveball. Okay? What does that mean? F of -2.
What is the value of x and y?
You got it reversed. What is the value of y when x is -2? So in other words, is there a dot there? Is there a y value at -2? That means look right at -2. What is it? It's 1. Okay. Questions on that? We're not done yet. Letter E. The limit as x approaches infinity of the function. Okay. As x approaches infinity, which direction are we talking about? Left, right, up, or down?
Right.
X approaches positive infinity, we're talking right. Agreed? So as you go right on this graph, which way are the y's going? Down. They're going down. So what would you write for an answer? They're going down forever. What do you call that? Negative infinity. Very good. So this means right. This means down. Because as you go right, the graph goes down. You follow what I'm saying? This is end behavior. Okay? Letter F. The limit as x approaches negative infinity of the function. Okay, this negative infinity for x means which direction? Left. Left forever. Go left forever, which way are the y's going? Up, which is positive infinity. Are they always going to be opposites? No, not necessarily. They are in this case. Okay? Now, in the last couple minutes, I want to give you a couple to try. You try this one. The limit as x approaches 2 from the left, positive 2. Then I want you to do 2 from the right. If you can do these correctly, you have done what I want you to leave with today. Okay? Now, before you get started, let me say this. I'm going to be giving you 2 different papers. This one is worksheet 1 on limits. This is your assignment for tonight. This will get you ready for the quiz. Okay? The assignment from yesterday that I messaged you about is optional, but it's a good review for the quiz. So I'm going to hand out this one first. You have to do this one. Okay? It should be 4, 4, 4, and does not exist. 4, 4, 4, E and E. Or error. You can put error if you want to.